China's Tiangong, the Heavenly Palace, isn't just a space station. It is the most modern outpost humanity has ever placed in the stars. While most of us were looking at the ground during the global shifts of 2021, China was looking up. In just 18 months, they did what took the rest of the world 30 years to achieve. They built a permanent, modular home in the heavens. At around 400 kilometers above Earth, this shining white laboratory circles the planet every 90 minutes, carrying a crew of Taikonaut who live, eat, and work inside a station that looks more like a futuristic apartment than a piece of Cold War hardware. For decades, the International Space Station was the undisputed crown jewel of human spaceflight, a collaboration between 5 space agencies and more than a dozen nations. But it's also more than 25 years old. And now, a new player has entered the game. Between 2021 and 2022, China built and fully assembled an entirely new station from the ground up in just 18 months. And it's not just smaller or newer, it's smarter. So strap in, because this is life inside China's Tiangong space station. But here's where the story gets complicated. While China was perfecting their sleek palace in orbit, something seismic was happening in South Texas. Elon Musk's SpaceX just achieved the unthinkable. On their latest Starship flights, they've managed to catch a 33-story booster out of mid-air using mechanical arms called chopsticks, and land it safely back at the launch site. This isn't just engineering theater. This changes everything about who controls the future of space. Tiangong was built to be the modern alternative to the aging ISS. But Starship is a paradigm shifter. While Tiangong offers roughly 110 cubic meters of internal volume, a single Starship offers over 1,000 cubic meters. One SpaceX ship has more living space than the entire International Space Station and Tiangong combined. China's strategy was smarter and sleeker. SpaceX's strategy is massive and reusable. And that reusability is the key. Every time SpaceX lands that booster and flies it again, they're cutting the cost of reaching orbit in half. Before Tiangong, China's human spaceflight ambitions were limited to a few test missions, small, single-module laboratories known as Tiangong-1 and Tiangong-2. They were stepping stones, short-term missions to test docking, life support, and crew endurance. But in April 2021, that all changed. China launched the Tianhe Core module, which literally translates to Harmony of the Heavens. At 16.6 meters long and 4.2 meters wide, it serves as the control center, power hub, and crew quarters of the entire station. A year later, the station began to take shape. In July 2022, the Wentian module, Quest for the Heavens, was added. It brought an entirely new science laboratory, additional living space, and an airlock designed for extravehicular activities, China's equivalent of NASA's spacewalks. Then in October 2022, the Mengtian module, Dreaming of the Heavens, joined the structure, completing the T-shaped station we see today. Mengtian is dedicated purely to research, housing advanced experiment racks and external mounting platforms for instruments that study everything from fluid physics to space materials. Each launch used China's most powerful rocket, the Long March 5B, lifting these massive modules into orbit one by one, where robotic arms and precision docking systems linked them together in a seamless ballet of engineering. By December 2022, the station was ready for its next milestone, the first in-orbit crew handover between Shenzhou 14 and Shenzhou 15. For the first time ever, 6 Takonauts were living and working inside Tiangong simultaneously, marking China's official transition to continuous human presence in orbit. Today, the Heavenly Palace is fully operational, a T-shaped, 3-module outpost orbiting Earth every hour and a half, and the foundation for what China says is only the first phase of its long-term plan for permanent human spaceflight. Step inside Tiangong and the first thing that strikes you isn't the size, it's the clarity, the light, the lines. Everything feels deliberate. People often say that Tiangong feels less like a space station and more like an Apple store in orbit. Despite appearances, the overall diameter of Tiangong's modules, about 4.2 meters, or 14 feet across, is almost identical to those of the International Space Station. But the difference lies in their length. On the ISS, America's Destiny Laboratory measures around 8.4 meters, or 28 feet. China's Wentian and Mengtian modules each stretch more than 18 meters, nearly 59 feet long, more than twice the internal volume. That means fewer junctions, fewer tight corridors, and a much more open, continuous workspace. Inside, the station is wrapped in smooth white paneling, concealing most of the cables and systems that clutter the ISS. Much of Tiangong's equipment is wirelessly connected, reducing the need for tangled cords and bulky routers. Everything from the air filtration units to the experiment racks is designed to be modular, replaceable, and neatly tucked away. The result is a minimalist, almost futuristic look. And it's not just aesthetic. Those clean surfaces are easier to disinfect. The bright LED panels reduce visual fatigue, and the evenly lit walls make for clearer video during live communications and science broadcasts. Behind those panels runs a network of power conduits and life support systems, designed to automatically reroute if a fault is detected. The modular sections connect through pressurized tunnels, each equipped with independent environmental control, meaning the crew can isolate a section of the station in seconds if there's a leak. Everything here, from the materials to the lighting, is meant to make life in orbit feel normal, even calm. And for Takonauts who spend months away from Earth, that serenity matters. It's a psychological advantage that the aging ISS simply cannot match. Aboard Tiangong, life follows a strict rhythm. At any given time, 3 Takonauts call the station home. During crew handovers, like in December 2022, that number briefly grows to 6, filling every bunk, every workstation, every meal seat. Their day begins just like ours, with a wake-up call from Mission Control in Beijing. After personal hygiene, which includes a rinse-free shampoo and wet wipes instead of showers, the crew gathers for breakfast. Meals are sealed, reheated, and labeled with each astronaut's name and nutritional plan. Then it's down to business. The morning hours are spent checking experiments, calibrating instruments, and performing maintenance. Everything from software updates to tightening loose handrails. By late morning, the crew joins a live video conference with engineers and scientists back on Earth. Here, mission planners outline the day's objectives, approve experiments, and schedule exercise sessions. Around midday, there's a mandatory 1-hour rest period, a long-standing tradition in China's spaceflight routines. Even astronauts in orbit need to recharge before the second half of their day. Afternoons are filled with research, biology, material science, fluid physics, depending on each module's experiment racks. Exercise sessions are scheduled for at least 2 hours daily to counteract muscle and bone loss. The gym might be the smallest in the universe, but it's surprisingly advanced. In the Tianhe core module, a compact treadmill and cycling station are bolted directly into the floor grid. Elastic harnesses keep the crew anchored as they jog, and soft straps reduce vibration so the entire station doesn't start bouncing with each stride. In the Mengtian module, there's a rowing and resistance machine, China's answer to the ISS's massive ARD, the Advanced Resistive Exercise Device, which can simulate up to 600 pounds of resistance. Tiangong's system is smaller, sleeker, and far more efficient, offering the same muscle activation in a fraction of the space. But here's where the story diverges from what we know about human spaceflight. Look closely at footage from inside Tiangong, and you'll notice something else: footholds and straps line the floors and walls. Unlike the free-floating astronauts of the ISS, Takonauts often prefer to stay anchored, giving their brains a stable, down, reference that reduces disorientation. And while official details are limited, CNSA prototypes have hinted at smart exercise suits, clothing embedded with gentle resistance bands that keep muscles engaged even during routine work. Think of it as a wearable gym, a subtle futuristic upgrade to fight the toll of microgravity. It's the kind of innovation that makes you realize, China didn't just copy the space station formula. They reimagined it. Evenings aboard Tiangong are more relaxed. Dinner together is a shared ritual, sometimes featuring favorites like kung pao chicken, braised pork, or dumplings. And here's where we get to the detail that truly separates Tiangong from every other human outpost in space. Afterward, the crew might stream a TV drama from Earth, read, or send video messages to their families. But before dinner, there's a moment that has never happened in any other space station before. The crew gathers in a galley, and right there, beside the fold-out dining table, sits a piece of technology no other space station has ever had, the world's first space microwave, developed by Gallants Aerospace. It took nearly 10 years of engineering to make it work. Unlike a home microwave that guzzles power, this one runs on extremely low wattage, and it's built to withstand launch vibrations and radiation without frying its circuits. On the International Space Station, astronauts use a warm water rehydrator. It takes about 30 minutes to heat a meal. Tiangong's microwave can cook dinner for 3 in just 7 minutes. It may sound trivial, but in space, that's revolutionary. Hot food is comfort. And for Taikonaut on month-long missions, that warmth isn't just physical, it's psychological. When you're 400 kilometers from home, eating hot food that tastes like it was made on Earth, that matters. That's the difference between surviving in space and thriving in space. Food in space has come a long way from toothpaste tubes and dehydrated mush. Inside Tiangong, the menu rivals that of a small restaurant, with over 120 varieties of meals carefully designed to meet nutritional needs and comfort cravings. Rice, noodles, fish, pork, chicken, vegetables, soups, and sauces, all pre-cooked, vacuum-sealed, and labeled for rotation. Each dish has to survive months of storage and the extreme vibrations of launch. Every few months, Tianzhou cargo ships dock with the station, delivering not just scientific supplies, but fresh produce. Apples, oranges, even cherry tomatoes. It's a small taste of home that keeps morale high when home is 400 kilometers below. When it's time to sleep, each taikonaut retreats to their private sleeping alcove. There are 6 small bunks in total, 3 in the Tianhe core module and 3 more in Wentian. Each one is barely larger than a closet, lined with soft insulation to block noise. Astronauts strap themselves upright in sleeping bags fixed to the wall, floating slightly inside as they drift off while orbiting Earth at 28,000 kilometers per hour. Inside every bunk, a small tablet for video calls, personal photos, and if you're lucky, a tiny window with the best view in the universe. They drift to sleep knowing that in 90 minutes, they'll see the sunrise over Earth again. And again. And again. 16 times a day. In Tiangong, every heartbeat, every flex of muscle, every drop of sweat is part of a grand experiment. Not just to survive in space, but to learn how humans can truly live there. At its core, Tiangong isn't just a home in space, it's a laboratory for the future of humanity beyond Earth. Every wall, every panel, every piece of equipment here is designed to explore how life and matter behave in microgravity. Across its 3 modules, Tiangong houses 23 internal experiment racks and 50 external platforms for instruments mounted on the hull. That's a dense scientific payload for a station of this size. Nearly every cubic meter serves a purpose. The fields of research are vast. Fluid physics, where scientists observe how liquids move without gravity's pull. Combustion, testing how flames behave when there's no up or down. Material science, studying alloys and semiconductors that can only form in microgravity. And biology and medicine, exploring how human cells adapt, or fail to, in the vacuum of space. One of Tiangong's most fascinating features lies in the Mengtian module, a dedicated airlock system for experiments. Here, astronauts can set up scientific packages inside the module, then load them into a sealed compartment. With the push of a button, the chamber depressurizes and opens to space, where a robotic arm either retrieves or installs the experiment on the station's exterior. No bulky spacewalk required. Inside, the crew is also working on space agriculture, cultivating lettuce and leafy greens in small hydroponic trays. The goal isn't just food, it's sustainability. Future experiments will test oxygen recycling systems that integrate with plant growth, creating the foundation for a closed life support loop on long-duration missions. These aren't abstract goals. They're blueprints for Mars. But Tiangong isn't operating in isolation. In 2023, 9 international research projects were approved in collaboration with the United Nations Office for Outer Space Affairs and the European Space Agency. These include studies on radiation shielding, protein crystallization, and cosmic dust analysis. Proof that China's heavenly palace is slowly opening its doors to the world's scientists. From the outside, Tiangong may look small, but inside it carries the ambitions of an entire civilization and the data that could define humanity's future among the stars. If science is Tiangong's heart, then its robotic arms are the hands that make it all possible. The station is equipped with 3 EVA suits stored in the Wentian module's airlock. Each is custom-tailored for its wearer and rated for up to 8 hours of continuous use. Spacewalks, or EVAs, extravehicular activities, are now a regular part of Tiangong's operations. From installing new equipment to testing repairs in the harsh vacuum of space, supporting them are the station's 2 mechanical giants. The Tianhe core module carries a 10-meter-long robotic arm, while Wentian adds a 5-meter arm of its own. Individually, they're powerful, but when combined, they form a single 15-meter system, rivaling the legendary Canadarm2 on the International Space Station. These arms are not just for heavy lifting. They can precisely grasp experiment modules, assist Taikonauts during spacewalks, or even reposition small spacecraft docking with Tiangong. During recent EVAs, the arms were used to install handrails and connectors across the station's exterior, allowing astronauts to move safely between modules during future maintenance. Each arm segment can pivot, rotate, and extend with millimeter precision, guided by operators inside the station or by mission control on Earth. In theory, these robotic limbs could one day grapple entire modules, helping assemble the next generation of Chinese orbital infrastructure, or even assist with spacecraft docking autonomously. They are extensions of human hands, reaching farther and working longer than any astronaut could. Together, they make Tiangong not just a home, but a living machine, evolving one orbit at a time. Now here's where the competitive landscape becomes critical to understand. While China was building Tiangong with meticulous precision, SpaceX was building towards something far larger. On their recent Starship test flights, Flight 4 in June 2024 and Flight 5 in October 2024, they've achieved something that changes the calculus of space forever: booster catch. That's right. A 33-story tall, 500-ton rocket booster, traveling at supersonic speeds, is caught in mid-air by mechanical arms attached to the launch tower. It's not science fiction anymore. It's happening in South Texas. And what does this mean for Tiangong? It means the cost per kilogram to reach orbit is about to plummet. SpaceX's Starship, once fully operational, will be able to put cargo into orbit for a fraction of what it costs China, the ISS, or anyone else. The Long March 5B, China's workhorse rocket, costs roughly $60 to $100 million per launch. Starship, once reusability is perfected, could cost $10 million or less. That's a 6x to 10x reduction in launch costs. In the world of space, that's a revolution. But it's not just about cost. It's about capacity. SpaceX's vision, articulated by Musk and his engineers, is to build not just a space station, but a space city. A self-sustaining, growing colony in orbit that can support hundreds of people. Tiangong, by contrast, is optimized for 3 to 6 people at a time. It's a masterpiece of engineering for a small crew. But it's a boutique operation. Starship is industrial scale. And as the ISS ages out by 2030, a date that's now set in stone, the question becomes, who fills that void? China has Tiangong. And for a moment, it looked like they'd have the only functioning space station in orbit. But Starship changes that equation. Private companies like Axiom Space are already planning to build commercial space stations that will dock with Starship. Blue Origin is working on their own orbital platforms. And SpaceX itself has hints at its own station designs. The competition is no longer about nations. It's about ecosystems. It's about who builds the infrastructure for the next era of human spaceflight. Tiangong may look complete, but this is only the beginning. China's space agency has already unveiled Phase 2, a plan to double the size of the station over the next few years. A new multi-docking adapter will be added to the front of the Tianhe core module, allowing for 3 additional laboratory modules to connect. This would expand Tiangong from its current 3-module configuration to 6, increasing its total habitable volume from roughly 20% to nearly 40% of the International Space Station. Once finished, the new setup would resemble 2 T-shapes stacked together, a cross-shaped structure that not only looks elegant but dramatically increases docking ports for visiting spacecraft and experiments. To build it, China plans to reuse its powerful Long March 5B rockets, the same boosters that launched the original modules in 2021 and 2022. Engineers are also considering incorporating a backup copy of the Tianhe core module, which was built as a contingency unit during the first phase. If attached, it would serve as a secondary command and living hub, giving Tiangong even greater redundancy and flexibility. But expansion isn't just about hardware, it's about people. China has confirmed that the first international astronaut from Pakistan is already in training to join a future mission. Talks are underway with other countries as China aims to make Tiangong a platform for global cooperation, open to partners who've never before had access to crewed orbital research. This is a subtle but powerful move. By opening Tiangong to international collaboration, China is positioning itself as the alternative to Western-dominated space infrastructure. Countries that were locked out of the ISS, or feared they would be, now have an option. And that matters geopolitically. Orbiting nearby, a new eye on the cosmos is preparing to join them. The Xuanjian Space Telescope, sometimes called the Chinese Hubble, is slated to launch around 2026. It will carry a 2-meter primary mirror and an astonishing 2.5 gigapixel camera with a field of view 300 times wider than the Hubble Space Telescope. Unlike Hubble, Xuanjian will share Tiangong's orbit, allowing it to periodically dock for refueling, maintenance, and upgrades, something no Western telescope has ever been able to do. This is revolutionary. It means the telescope isn't a one-time launch that lives or dies by its initial engineering. It's a platform that evolves. If a detector fails, a taikonaut can float over and fix it. If new technology emerges, it can be integrated. If you want to upgrade the camera, you dock, swap components, and launch again. Together, Tiangong and Xuanjian will form the core of China's orbital science ecosystem, combining human presence with robotic observation, a partnership between machine precision and human intuition. Meanwhile, back in South Texas, SpaceX is pushing forward with its own vision. Elon Musk has stated publicly that Starship will be used for point-to-point transportation on Earth, lunar missions, and eventually, missions to Mars. But before Mars, there's a waypoint, orbital refueling. SpaceX needs to master the ability to dock two starships in orbit, transfer propellant between them, and send a fully refueled ship to the moon or beyond. That's coming soon. Some reports suggest the first orbital refueling test could happen in 2025. If successful, it changes everything. It means Starship becomes not just a taxi to orbit, but a ferry, a cargo hauler, and a foundation for massive in-orbit infrastructure. The ISS, that beautiful symbol of international cooperation that orbited Earth for 30 years, is being retired. By 2031, it will be deorbited, burning up in the atmosphere in a controlled descent. It's the end of an era. But what replaces it? That's the question being answered right now, in real time, by the actions of China, SpaceX, Blue Origin, and a host of private companies. Tiangong represents the nation-state model, a government-funded, long-term commitment to permanent human presence in space. It's orderly, methodical, and designed to last decades. Starship and the ecosystem growing around it represents the commercial model, rapid iteration, massive scale, and the goal of making spaceflight as routine as airline travel. These aren't necessarily opposed. They could be complementary. Chinese astronauts could visit commercial space stations. SpaceX rockets could service Tiangong modules. But as things stand today, they're on different paths, with different philosophies, and different end games. The Heavenly Palace is open. It's orbiting Earth right now, with Taikonaut conducting experiments, growing food, and proving that humanity can thrive in the void. But it's not the only game in town anymore. The age of singular dominance, whether by the ISS, Tiangong, or Starship, is over. We're entering an age of competition, plurality, and possibility. And that's the shocking reality: space is no longer a frontier that one nation owns. It's a frontier that multiple nations, multiple companies, and multiple visions are racing to shape. The question isn't whether humanity will live in space. It's who will build the cities we live in, and what those cities will look like. Tiangong is beautiful, sleek, and brilliant. But it's also the old guard of the space era, the nation-state model taken to its logical conclusion. Starship, for all its experimental chaos and reusable booster catches, represents something different: the future. A future where going to space is cheap enough, easy enough, and accessible enough that the entire human relationship to the cosmos changes. The Heavenly Palace is real. The data gathered there will shape missions to Mars. The international partnerships being forged in orbit will outlast any political disagreements on Earth. And the Takonauts floating inside, eating hot meals cooked in the first space microwave, conducting experiments that couldn't be done anywhere else, they are proof that humanity's next chapter is being written not in boardrooms or government offices, but in the silence of orbit, 400 kilometers above the planet we call home.